Today on Jeff the Maker, we're going to make a stoplight for a warehouse door. There are many ways I could have gone about building this system, but I chose to use a microcontroller. The first step was to design a schematic. It's a basic system. There are two switches mounted on the garage door track, one at the top and one at the bottom. When the door is closed, the red light will be on. When the door is open, the green light will be on. When the door is in motion, the red and yellow lights will flash because you can't design a system with LEDs and not have them blink. The microcontroller I chose to use is the Parallax BS2, which requires a supply voltage of 5 volts DC. The power supply I'm using has a dual output of 5 volts and 12 volts. I decided to add a 5-volt voltage regulator as a safety precaution for the microcontroller. I chose to use the LM2940. The switches are designed to mount to a garage door track and are usually used in security alarm systems. I will show you how they work in a little bit. The LED light tower operates on 12 volts DC, so I needed to interface between them and the microcontroller, and for this I chose to use a MOSFET, specifically the FQP30N06L. After I had the schematic completed, I designed the printed circuit board. The layout was very similar to the schematic I made. This is a dual layer board where the red traces are on top and the green traces are on the bottom. Five days after submitting my files, I had my boards, and it was time to start soldering on the components. I started with the parts that were flush to the board's surface, such as the resistors and the chip carrier. I then moved on to the screw cages, and then finally the transistors and the voltage regulator. Here is a completed board. If you look closely, I missed a solder joint on the chip carrier. This led to some confusion and a few cuss words when I powered it up and tested the circuit for the first time. After getting all the components soldered on, it was time to mount the power supply and control circuit in the electrical enclosure. I used some 632 nylon standoffs to lift the board off the metal back panel. I used the control board and the power supply board to locate where my holes should be and then drilled them out with the proper size drill bit. I used a larger bit to deburr the back side of the panel. Here you can see the actual enclosure I will be using. Now it was time to start installing the system, which meant I was able to take a cruise through the warehouse on the scissors lift. I was lucky there was a junction box on the wall that I could tap into for power, so I decided to mount the enclosure right next to it. I marked out the hole locations of the enclosure and started drilling holes, only to quickly realize that my cordless drill was not going to get the job done, and I needed to break out the hammer drill. Plastic anchors are the easiest way to mount items to a cinder block wall. For a clean look, I ran all the wiring through conduit, even though this isn't necessary because it's a low voltage system. The knockouts on this enclosure did not match the spacing of the existing electrical box, so I needed to bend a small offset in the conduit. This is easily done by putting a slight bend in the conduit, rotating it 180 degrees, and bending it again to the same angle. Installing the conduit is a simple task. Insert it into the connector on your enclosure, make sure it is level, mark out where your conduit hangers need to go, drill a hole, and insert an anchor. Here is the LED light tower I used for the system. I needed to build a shelf for it, so I just made one out of some scrap pieces of plywood. In order to mount the 3/8 flexible conduit to the shelf, I drilled a hole in the bottom and attached a blank cover for a 4x4 electrical box that had a center knockout. No fancy woodworking here, just some glue and staples. I painted the shelf black and attached it to the wall with the same plastic anchors I had been using. I then pulled all the wires I needed and made my connections. And yes, that is a GoPro strapped to my head. But unfortunately, I lost some footage from this point on, but here you can see how the flexible conduit attaches to the shelf. Here are the switches I used. These are known as reed switches. The piece that mounts to the door is a magnet. When it is near the switch, the magnetic pull causes two metal contacts in the switch housing to make contact, thus closing the circuit. There is a switch and magnet mounted near the top and bottom of the door. Well, hopefully this stoplight will put an end to this door being struck by trucks leaving this warehouse. Let me know in the comments how you would have built this system, and thanks for watching. Please like and subscribe.